Okay, so algebra is an important component of this class. First semester, we're concentrating on college algebra. So it's important that all those rules you learned in Algebra 1 and Algebra 2 are still in your brain. The first thing we're going to talk about is order of operations. So let's look at this first problem here. You may recall back in the day, order of operations, please excuse my dear Aunt Sally. Some teachers even call it PEMDAS. I don't know, but please excuse my dear Aunt Sally. The thing to recall is that the P stands for parentheses, but any sort of grouping you need to do inside that grouping symbol first. Then you'll work your way outside if there's some kind of exponent on it, and then you'll multiply and divide from left to right before you finally add and subtract from left to right. So that's that PEMDAS. That doesn't go away even if you take Calc 1 or Calc 2 or Calc 3 or even higher mathematically. It is something that is a fast and hard rule forever. So please make sure you know those rules. So let's go inside the parentheses and apply the rules. -1 minus 1, and that's in the parenthesis, so write it that way. So that would be -2 squared. Note that -2 squared with the negative on the outside of the parenthesis and -2 squared with it on the inside of the parenthesis are two very distinctly different things. This top one is the opposite of 2 squared. The bottom one is the quantity of -2 squared. So you'll see that you'll get different things. So be careful and be mindful of are the parentheses including that thing or the parentheses not including that thing. That's very important. Here we have a negative times a negative. So two negatives are going to make a positive. And so that's going to be a positive 6. Now remember, PEMDAS, please excuse my dear Aunt Sally, says we got to work on that, any powers that are on the outside. So let's do that next. -2 squared is going to become a 4. 6 squared is a 36. And then finally, 4 minus 36 is -32. Okay. Any questions about that? Okay, let's look at number 4. Anybody remember the distributive property? Yes, can you tell me what we need to do as our first step for this problem?
We need to multiply the 4 with the 2 and then multiply the 4 with the 1.
Exactly. So we're going to take that 4, we're going to distribute it. It is going to multiply by each of the terms that are inside that parenthesis. If there was more than 2 terms, we would just distribute it. We would do it to everything. So let's multiply that in. We're going to get 8v plus 4 minus 7. Now at this point, order of operations tells us we would do any multiplication before we do any addition and subtraction. Well, 8v is something we don't know what v is. So that's why we got to get stuck. And the only thing you can do at this point is combine like terms. So 4 and the 7 are both like terms. So 4 minus 7 is negative, bless you, -3. So our final answer would be 8v minus 3. You can't go further unless some things happen. If they told us what v was, we might be able to do something. If they asked you somehow to factor or do something further, but if they just say the word simplify, that's all you do, okay? Now, these problems that you see the little blue before them, some of you might have used last year in your Algebra 2 class, Alex. These problems are similar to what you're going to see in Alex. So I'm always going to give you at least one example of something that you're going to see in Alex so that you can be familiar with how they worded it. I'm never going to leave you hanging. I'm always going to try to give you some examples of what's out there. Okay? Next. Rules of exponents. There's a few different rules. I'm going to give you 3 of them. First rule is if the bases are alike and you are multiplying, you keep the base, you add the exponents. Okay? Next rule. If the bases are alike and you're dividing, keep the base, subtract the exponents. And then third rule, I might even give you a 4th one. If you have a power on the inside and a power on the outside of parentheses, that's when you multiply. And then anything to the 0 power equals 1, whether it's just touching that thing or if it's on the outside of a parenthesis. So that's some rules back from algebra that you will use in a pre-calc class, you would use in a calculus class, just important rules about powers. Okay, let's keep going. So, multiplication is commutative. You can do multiplication in any order that you want. So, my suggestion when you're doing this problem, my suggestion will be, let's take our numerical components, the 4, the 2, and the 5. Let's think of them first. And then I tend to be, you will find, a little bit of an absent-minded professor. I miss little stupid little things. So if I ever miss something, I am not offended. Let me know if I've missed it. But to help me, I've learned that if I go alphabetically, it's helpful. So I'm going to write my W's next. And if I don't have a power showing, I like to show that one so that I don't forget it. Again, I make those little mistakes, so I like to make sure that I can try to prevent that. And then we've got our Y's. Okay. Now that we have that, and we're organized it, now you can do some of that organization in your head. And I'm not a teacher that you need to show every single step, or John needs to show 5 steps exactly, and Mary needs to show 5 steps. I don't work like that. But you need to at least show me something that I knew where your thinking was, because I can't help you, one, if I don't see it, because I don't know exactly what was in your head. I'm not a mind reader. And two, I just need to verify it's your work and not someone else's. So even that one little step is all I need. If you're a person that likes to show me 10 steps, go for it. That's great. If you want to show me 1 or 2, that's okay too. Okay. So let's multiply the 4 and the 2 and the 5. I like to multiply in my head when I can avoid that calculator. Isn't 2 times 5 a nice multiplication? That 10. And 4 times 10, 40. So that's an easy way to do that in your head. Okay? You can do multiplication in any order. We could do 4 times 2 is 8 times 5 is 42. For the W's, we're going to add those exponents together. For the Y's, we're going to add those exponents together and keep that base. Okay? Any questions about that one? Let's take a look at this one. It says understanding the power rules. So we went over the power rules, but this is trying to illustrate what the power rules are. So the first one says write a squared to the 4th without exponents. So what they're looking for is a times 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 a. You'll notice we have 4 sets of 2. A squared is a times a, and then we have a second one, and a third one, and a fourth one. So they just want a big string to prove to you that we're going to get a to the 8th. That's all they were doing with that rule, to remind you that the reason the multiplication rule works is because we get 4 sets of 2 pairs of A's multiplied together. That's why we have 8 of them. That's all they want there. Sometimes, Alex, the way that they word their questions, it makes it seem harder than it is. You guys are smart. You'll want to overthink it. Don't overthink it. If you have a question how it's worded, let me know. I will always try to give you an actual example. I will always try to provide that example to you so that you have it. Okay? Okay. Any questions there? Are we good with that one? Okay. Let's look on the second page here. It says power rules with positive exponents. Here's my suggestion if you have a fraction inside of a parenthesis like this. I would suggest making sure your fraction is reduced as much as possible before you move to the power on the outside. This fraction, there's nothing we can do to make it any nicer. There's no numbers that can reduce. There's no letters that can reduce. If there were, do that first. Then let's apply the power on the outside. Now, our fraction is reduced as much as possible, so we're going to just move to the square on the outside. The rule is, remember, that we are going to double all the powers. The numbers get squared. So u squared is going to become u to the 4th. Now, the negative 6 is really negative 6 squared. So that's negative 6 times negative 6, which is a positive 36. And then we have a w to the 8th. There's nothing else, I don't even know why I put it. There's nothing else we can do to that one. You can't reduce it. Always just kind of glance at it. Is there a way I could reduce it a little bit further? If there is, do it. Otherwise, there's nothing we can do about it right now. Okay. Everyone okay with that one? Okay, let's go on to this one. So here we have two distinct quantities, one of which there's this power here. So when you got that power there, my suggestion would be let's deal with this quantity first, then we'll multiply by that chunk, okay? Okay. So I'm not going to do anything to this first quantity, so just write it. Now the second quantity, I have to cube all of the pieces. So I think of, let's deal with cubing the numerical part. What's the numerical part? The negative one that's out in front. And then let's deal with cubing all the other stuff, okay? Okay. So when we cube it, we get still a negative. Negative 1 times negative 1 times negative 1 is still negative 1. Remember that 3 negatives will multiply together to still be a negative. An odd number of negative symbols stays negative. An even number of negative symbols will become a positive. Remember that. Okay. So we're going to get x to the 9th, y to the 3rd, z to the 9th. Now I always put a little slash through the middle of my z's because my z's and 2's sometimes kind of look alike. So I will make that little slash, this little slash on my z on purpose just so you can see it's a z. So if you enter a college math class, many math professors are going to do that. That's very common. If you want to do it, fine. You don't have to. Just try to make your z's very squared off compared to a 2 if you don't put a little slash in the middle of it. And now we're ready to actually multiply the junk together. So multiply the numerical parts. You could even rearrange the order if you want. You know, put the x's together, put the numbers together. Do you have to do this part? No. Sometimes it's nice to see them next to each other. Do I have to do it? No. Is it helpful sometimes? Yes. We will get a final answer of positive 2 because those two negatives are going to cancel out. I'm going to get an x to an 11, a y to a 7, and a z to an 11. When you get into ALEKS, I was hoping we could get into ALEKS today, but I'm thinking it's going to be tomorrow. When you are able to get into ALEKS, there is a tool, a little button that allows you to enter fractions, allows you to enter things with a power on it. I am not super concerned with ALEKS too much. You are going to get some points for doing some problems in there, but it is just a nice tool for you to practice some of this stuff. Okay. Any questions on that one? We good with that? You think? Okay. Let's take a look at one more fractional one. For the fractional ones, we're going to square everything on the inside for the top. We're going to cube everything on the inside for the bottom. Let's do those things individually because they're each, it's kind of like that PEMDAS thing. We're stuck inside that parenthesis first before we can go further. So let's do that. Okay. We're going to get 16 a to the 8th over 27 a to the 15th. Now at this point, 16 is multiples of 4. 27 is multiples of 3. Those things aren't going to reduce or cancel, okay? But the A's, we can deal with that. Now remember how that one example says to write it without exponents, and we wrote out 8 of those things. It was a to the 8th. You can think of the same thing kind of happen here. There's technically 8 of those A's on top, 15 of those A's on the bottom. So to reduce it without doing the subtraction rule, just to put it back where it belongs, because look how it says the words positive exponents. What you want to do is just think, where do I have the extra A's and how many? So 1, where do we have the extra A's? In the denominator. How many extra? 7 of them. So when we write that, we have 7 A's in our denominator. And by keeping it that in the denominator, we're going to keep it a positive exponent. If we bring it to the top, it's going to be an a to the negative 7 at the top, and we don't want that. So if you ever have a negative exponent, just flip its location, and then it becomes a positive exponent. Any questions about how we got that one? Remembering some algebra here a little bit? Okay, let's take a look at this. Let's see how far we're going to get. Yeah, I think we can get to this. Yeah, let's stop at this one, and then we'll talk about some homework. Okay, so let's take a look at this one. Earlier I told you there was powers of 0. A power of 0 becomes 1. Now let's look at the difference in this first thing compared to the second one. In this parenthesis is this fraction. That's the thing that's going to become a 1. Okay? The 2 on the outside is not included in this process. So this first one is really 2 times 1, or an answer of 2. Okay? Now let's look at the second one and how it's different. This one, only the 2 is to the 0, but the negative is not. So include the negative on the outside, and it's just going to become negative 1. Everybody understand about those powers of 0 and how those work? Anything to the 0 power is 1. So if it's in a parenthesis, that stuff and only that stuff is going to turn into 1. If it's something on the outside, it's just going to multiply by 1. Okay. Let's take a look at polynomial stuff. Just got 3 more to think about. The first one is about adding like terms. Okay, so let's do this. First thing I would suggest, back in Algebra 1 or 2, if you see a negative in front of a quantity, my suggestion is distribute it in first before you do anything else. Now, these front pieces here don't have anything or have a positive in front. If that's the case, that positive in front is like multiplying by positive 1. Does that change anything? No. So first I'm just going to rewrite it without the parentheses. So I'm going to write 3y squared plus 7y minus 3 minus 5y squared plus 7y plus 1. And now distribute that negative on the end. That's going to give me negative 5y squared plus 6y plus 7. Now my suggestion to you is when you get to the point where we're actually in ALEX, always have a sheet of paper sitting next to you. The way ALEX works, if you're getting them right, you might only have to do, don't quote me because I've never used ALEX or haven't used it for years. I haven't used it since I taught a night class at YSU a few years ago. But it's something like, if you get them right, you only have to do 3 problems. If you get them wrong, you have to do a lot more. By having a sheet of paper next to you that you're writing that stuff out, you're going to make less mistakes than trying to do it in your head. So as you're working on your ALEX to get done with things quicker, have a sheet of paper next to you. Have a little notebook for this class. You don't have to, but it's helpful. I always have paper on the back table. Feel free anytime to grab yourself a sheet of paper. I have a recycle box, so if you need to throw away any water bottles or paper, I would prefer you recycle them. Okay, now let's go back here to this problem. Like terms can be combined. They have to have the same variable with the same exact powers. So this negative 3y squared, this negative 5y squared, and this negative 5y squared can be combined. Okay, so let's mush those together. Negative 3 minus 5 is negative 13y squared. Remember, you add the front coefficients, the y squared doesn't change. That's how many y squares we have. Next, we have a 7y and a 7y and a 6y. So that's a total of 20 y's. And then we have just normal numbers. Negative 3 plus 1 is negative 2, plus 7 is positive 5. Get in the habit now, your algebra teacher might have told you this as well, by getting things in descending order. It's not necessary, but it's very helpful because of some of the applications we do to polynomials. That descending order is helpful. So I've always just kind of trained myself to do that, and I would suggest for you guys, highest power to lowest power is going to be helpful to you. One, it'll keep you organized. Two, from future stuff, it's going to be helpful. Okay, everybody got that one? Okay, 2 more, and then we're going to talk about homework. We talked earlier about the distributive property, right? This is an example of the distributive property with binomials, binomials. Some algebra teachers give it a name, they call it FOIL. And in your Algebra 1 class, they might call it FOIL. It's just the distributive property with a little bit of extra stuff. Remember, you're going to distribute the 4y. Once you do that, you're going to distribute the 3. Okay? So let's distribute the 4y. So if I distribute the 4y to the second quantity, that's 12y squared minus 28y. Okay? Now distribute the 3. If the 3 had a negative with it, I would think about that as a negative 3. But I'm distributing the whole piece, the positive 3. And so when I distribute positive 3, I get 9y minus 21. Okay. Now, the last piece of this puzzle is just look. You probably are going to have some like terms. So when they say simplify, that's as far as you need to go. So these two things right here happen to have the same exact power and the same exact variables. They're like terms, mush them together.
The same way it's hard for me to put whatever I do in my head down on paper.
Oh, so next, let's do it one more time. I want you to try this one. You're going to distribute just like we did in the problem before. This one's actually a little easier, but something tricky happens. Try this one on your own, and then we are going to talk about your homework. Yes?
Earlier you
Everyone, when you're done with this, if you look up on the board, I have given you the answer. C squared minus 100 is your answer. You might recall that if you multiply two conjugates together, that a plus b and that a minus b, you get that difference of squares each time, a squared minus b squared. So that's what happened here. Those middle two terms ended up canceling out. That's a formula that's very helpful. So if you looked at that and saw, oh, that's a difference of squares, I'm going to get c squared minus 100. Great. That's not a bad thing to know. Okay. So you're not ready to turn this in yet because we haven't finished it, but we will finish it maybe tomorrow. We'll see. When we finish it, you'll turn that into Google Classroom. At this time, go back into Classroom if you haven't got it. And there is one more review homework. I think it probably says Algebra Review Homework. And this is what it is. And if you could please put it into Google Classroom. No, from Google Classroom into Notability. we are going to now talk about this. So this is actually your homework for the week. It is due on Friday by midnight. You will upload it into Google Classroom when you are finished. Although it's not due till Friday, today's Wednesday, I want to show you, based on what we reviewed, what you're ready to do. Now, could you please cross out for me? I don't care about number 1, 2, 5, or 6. So cross out 1, 2, 5, or 6. They are not required. But today, based on what we reviewed, you are ready to do 7, 8, 9, 10, 11, 12, 19, 20, 21, 22. I think that's where you're ready to do. So you're ready to do those problems. So for the remainder of class, I would work on those. Okay, so work on those problems, although again, this assignment is not due until Friday. Working on those problems right now in class, I think would be a good place to start, okay? So work on those, and if you get stuck on any, just let me know. I'd be more than happy to help you.